Well, how can we make visualizations more scalable? And how can we keep them interactive even as the data volumes get really large? We're going to use a standard interaction technique called overview plus detail, where I drag out a selection region or brush above, and of course I'm filtering the view below. So I get my overview in the top chart, and then the bottom chart is showing me the details. One chart serves as an input device then to configure the other. It knows that, hey, well, I can draw this selection, and it knows that it's going to be limited over the space of pixels that I can draw it. But long story short, it takes all of that information and uses it to pre-aggregate the data so that on every frame when we're updating, it actually already has it's already at least halfway or more to the answer. And so it can query these much smaller pre-aggregated tables, similar to what you might get from a data cube, but hyper specific to your use case right here. And this allows us to give us some 100 and even some cases 1000x improvements in the latency for answering these queries.
That's the rabbit in the hat trick, because the second pre-aggregate is conditioned upon the first selection. And so with that evidence of user intent, as they move their mouse to the next view, you're consistently narrowing the scope.
And so one is just making these dashboards or visualizations with multiple views just much more flexible, not just as single static snapshots, which of course are already valuable, but really tools for exploration and follow-up questions.
Let's make sense of this.
Let's make sense.
Sensemakers.
Jeff Heer, welcome to the show.
Hi, thanks for having me.
Yeah, we've just met, and I'm so thrilled to have you join us all the way from Berlin. It's a lovely city over there. We had Ellie on last week, and she showed us just the amazing performance and the unique concept that you've got with Ridge, in the way that you're getting this ultra fast performance in the browser combined with a data agent to speed up analytics, both in the response times, which your piece has a part for Mosaic, and then also the Ridge platform itself just providing faster analytics because the user can get these long tail answers with a conversational data agent all working off of the same data set that's been injected into the browser. And so we're just super curious, how does your piece work? Because, you know, Ellie's told us that the Mosaic part is really playing this significant role in the performance and in the data visualization piece. And I just thought it'd be super neat to have you come. I don't know anything about Mosaic, and I think you and Jonathan have met in the past, and he may know a little bit more than I. You could just give us a tour of what your piece of the puzzle is?
Sure, I'd be happy to. Maybe I'll start by backing up a bit by just noting, you know, I've been involved in open source efforts and visualization for many years now, and really thrilled to be able to contribute to libraries like D3 and Vega Lite over the years, both as a researcher, but also someone who's really excited to put this out there in the world for people to use. And that whole trajectory has been about building visualization and languages and systems that people can use to build their own rich and interactive visual data experiences. But the whole time, we've also had this other research thread really drawing on databases as well as visualization. Like, well, how can we make visualizations more scalable? And how can we keep them interactive even as the data volumes get really large? And so kind of this decade-long quest, it's been quite a delight to have this come together in the Mosaic project, where it's really thinking about what is the middle layer that sits between a data store and the visualizations, and does the coordination work to help make them really scalable. And so that's sort of the background on leading to the project that, of course, is an open source project in its own right, but also the infrastructure that we're building on at Ridge.
Got it. Okay, when you say middleware layer, that's not necessarily the same thing as the database itself. So like Tableau would have had a hyper extract, and Ridge is using DuckDB. And when you say middleware coordination, I think I interpret that that's something different than just the database that's in between the analytics and the user?
That's right. So Mosaic runs in the browser, and you can imagine it's basically what the different visualization components, but not just visualizations, it can also be things like input widgets, like what should the values in the menu be? Well, those are values that came from your database, or tables that you want to look at. So there's all these different interactive components that are driven by data. And basically they subscribe to Mosaic as an architecture layer to basically ask for that data. And then Mosaic in turn will then turn around and then ask the database, for example, DuckDB, for that data. But along the way, it gets to see all of these queries. But as we'll talk about, also sees what the potential interactions are going to be, and then uses that to provide a variety of optimizations that make that process of interactively updating the data much, much faster. In some cases, multiple orders of magnitude.
Got it. Yeah. And for anybody who didn't watch the previous conversation with Ellie Fields, I suggest to definitely go back to that. But the interactivity was amazing because she would just drag her selection lasso around a certain visualization, and everything on the view was just instantly interactive, a lot of kind of interactive brushing. And I think that's what you're talking about.
Yeah. So maybe it makes sense to just jump into a demo so we can see what I'm talking about, and then take it from there. Hopefully you're seeing my browser showing a time series visualization. So in this case, you're seeing two different time series. Obviously, it's showing the same data. And as the x-axis tries to convey here, this is just demo data, but it's showing it has like 50,000 different time samples. And we're going to use a standard interaction technique called overview plus detail, where I drag out a selection region or brush above. And of course, I'm filtering the view below. So I get my overview in the top chart, and then the bottom chart is showing me the details. And so I can zoom and pan using that selection. So one chart serves as an input device then to configure the other. Now, the one issue is that this could be really slow. Like if I'm redrawing up to 50,000 points on each frame, that's kind of wasteful. But 50,000 is actually nothing. I mean, in many cases, you're talking about millions or more points in a time series. And in fact, some of the browsers, if you try and draw a line with more than 1 million points, it just won't. You'll get nothing on the screen. And so this is a case of where we're applying a visualization-specific optimization. In this case, it's a trick developed in the database community known as M4. But what it does is it says, like, well, let's only query for the points that we need to draw the time series. And if we have multiple points per pixel, we actually don't need all of them. We can have a smart optimization that actually pulls a lot less data in, but still renders in a way that looks identical to as if I had drawn all the points. So this is just one example where, like, using components in Mosaic, we can be smart about the kinds of queries we're generating in a way that's taking advantage of knowledge about the visualization itself. So in this case, because we're using a line or an area chart, the system can apply that optimization.
Right, and so you'll have different optimizations for different visualization types. I imagine a scatter plot might have its own kind of similar optimizations that you do that are specific to that unique chart type.
Right. And so one of the nice things about Mosaic is it doesn't need to know all of these internally. Like each visualization component, where it knows what it's doing, can generate queries that then participate in the architecture. But where things start to get even maybe more interesting is these optimizations that span different stages of someone's exploration and experience. And these are things that are applied absolutely automatically by Mosaic. So in this case, we're looking at a different data set. This is real data from US flights, and it's showing a histogram of arrival delay above, departure time, so what time in the local time zone a flight left, and then down below we see a histogram about the distance flown, so how far did that flight go.
And I'm guessing there's 10 million records in this data set?
Yeah, and in this case, we're doing purely in the browser, but we've loaded from a Parquet file, and so we're working with 10 million data points. And so while we can get a nice univariate summary for each one of these dimensions, the real richness comes through interaction. So for example, I drag out a region, I might want to ask questions like, well, what does the distribution look like for these flights that were delayed, say, 50 minutes or more? And you can see, how this distribution changes, right? Like, oh, well, maybe unsurprising, but they leave later in the day. Right. So yeah, obviously, if you want to be on time, as you probably know, you want to get that first flight that's already there instead of that delayed flight that's now cascading through the system. We can ask that same type of question, but maybe like, what about the flights that get in early? And there's this interesting maybe multimodal distribution here, but you'll notice if you look below to that third histogram, the flights also tend to be further. Like here, you can see most flights are actually pretty short. And then the ones that are getting in early, maybe unsurprisingly again, but it's because they were going a longer distance. Maybe you got a tailwind. The odds that you can get there ahead of time are higher, and you're seeing that play out.
So in terms of fast analytics, I mean, what I'm seeing from a consumer of data is that this is giving me a richness and a depth of the ability to get that interactivity at deeper levels of detail on deeper levels of granularity very quickly. And so I think what I'm seeing is the opportunity for an increased volume of sophistication of analysis that's coming as a result of this.
Yeah, I would certainly hope so. I mean, I think that there's a couple of roadblocks that people might face with interactivity. And I think the first, the one that Mosaic is really intended to address, is that it's hard to implement, it's hard to do well, and even then it's hard to scale. And so one is just making these dashboards or visualizations with multiple views just much more flexible, not just as single static snapshots, which of course are already valuable, but really tools for exploration and follow-up questions.
Yeah, and I think a lot of consumers of, Tableau has been all the rage for the last decade or more, 20 years. A lot of the frustration of the consumers of Tableau dashboards was that interactivity would be quite slow. And then if they wanted to change something about the interactivity, they would need to route a request through an analytics department to have somebody build it for them. And so did I get it right that Mosaic is actually handling this interlinking between these different visualizations on the fly automatically so that the author of the visualization, the consumer of the visualization, don't even need to bother with it at all?
Yeah, you still specify what interaction you want and kind of what you want it to do. Like I want a brush and I want it to filter, but that's the level of specification. Then the framework takes care of the rest. There's a couple of things going on here. If I go under advanced options, let me turn one of the options off and then you can see what happens. So now you'll notice how much slower it is. We're still leveraging the database. And for many dashboards, this is actually a huge improvement. Like you're not getting these super long server round trips, but you still notice how laggy it is. And this is what happens when on every frame, we're just basically sending the same initial query and we're reevaluating it against the database. But instead, if I turn on one of these optimizations, it actually looks at both the granularity of these visualizations. So the fact that, these have bins and we can take advantage of those, but it also knows what interactions I'm going to do. It knows that, hey, well, I can draw this selection and it knows that it's going to be limited over the space of pixels that I can draw it. But long story short, it takes all of that information and uses it to pre-aggregate the data so that on every frame when we're updating, it actually already has it's already at least halfway or more to the answer. And so it can query these much smaller pre-aggregated tables, similar to what you might get from a data cube, but hyper specific to your use case right here. And this allows us to give us sometimes 100 and even some cases 1000x improvements in the latency for answering these queries. And then I'll note that right now, this is running purely in the browser. So in this case, we're using DuckDB as a backing database and using its WebAssembly version here. We can also run this against DuckDB running locally, for instance, with a little server script that we provide. But in this way, you have some flexibility about where your data lives, including bringing it all the way out to the edge so it can happen directly there in people's browsers.
Well, I have two thoughts. One of them is one of the things struck me in reading the Mosaic paper, and we'll share a link to that and everything, is there were these comparisons of Mosaic interactions to various other tools. And in it, one of the reference lines was 60 frames per second updates, like being able to pull that off. And that totally changes things when we're going from effectively seconds per frame in other tools into frames per second of updates. And that speed of updates is really impressive for me. And another piece of this for me, and kind of a question, is on the data side, like this is 10 million records. Were all 10 million records loaded into the browser at this point, and then it's working on top of that? Or was there some level of pre-aggregation, given that foreknowledge of this visualization has 3 charts, they're binned in a certain way, and so on?
So in this case, it's all on the fly. So the full 10 million record file was loaded. So the Parquet file as we bring into DuckDB. And then the visualization spec is parsed and rendered out. And then the queries that are driving each one of these charts and those defined interactors, in this case, those selection brushes, are then all the information it needs in order to automatically optimize for the updates that you're seeing here.
So when you're clicking that pre-aggregate button, is that pre-aggregating as soon as that's clicked, or is that more a dynamic as somebody's doing something?
Great question. So when is it happening? So we don't want to pre-compute every possible pre-aggregate because most of them will be unused. And in fact, if I make a selection here for arrival delay, well, now I actually need a different pre-aggregation for the other two charts because I've actually already filtered the data. So any pre-aggregation I've done before, it may be still holding on to this old data that I've now filtered out. So now when I actually, to answer your question, when I mouse down to this second chart, it was the mouse entering the chart that actually kicked off the pre-aggregation. So it's like that gives us typically a second or so before people actually click and drag. And we can create those aggregations on the fly for data of this size without even people realizing. And so now I've actually created an entirely new pre-aggregate that's conditioned on what I did before.
So you're taking that evidence of user intent as a way to run a query that is already taking advantage of the other filter settings, the brushing settings that are already there. And so at that point that the user is starting to do something, there's a pre-aggregated data set to operate on that is 10% of the size, 1% of the size.
1% typically, yeah. So we've gone usually from like 10 million. I think in this case, it goes typically from about 10 million rows to maybe about 2 to 5,000 in the pre-aggregated view.
That's the rabbit in the hat trick because the second pre-aggregate is conditioned upon the first selection. And so with that evidence of user intent, as they move their mouse to the next view, you're consistently narrowing the scope. And so now it makes sense why this thing is so glitteringly fast, which has got to just be delightful because everybody's been conditioned by the responsiveness of their smartphone. And so when you go to another BI tool or legacy BI tools that have to make this round trip to a server and don't have this speed, it just feels so much terribly slower.
Now, and I'm going to go back to the data piece because 10 million records is fantastic. But what happens when somebody has 100 million, billions of records? Because that's some of what in my daily work, I'm running into people who are, how can I get sub-second rendering times on billions of records?
Yeah, it's a great question. And so couple things in response. I mean, so the first thing to point out is that, the Mosaic architecture resides in the browser as this coordinator, but the database can live anywhere. So we've been talking about DuckDB running in WebAssembly here in the browser. Now, I'm not going to want to load a billion element database into my browser, probably because of bandwidth reasons. But even then, I'm very likely to overwhelm the memory resources I have, that the browser provides. Mm-hmm. So we have other options. We can, run the database locally. So if you want to use the full power of your laptop, so that means not just memory, not just being able to spill over to disk, but also getting that full parallelism that your processor provides. So you get speed from that. That's another option. And then, of course, it could be a remote server as well, where you might even have a higher resourced machine. And so we can run this with larger data sets. It's just then you might want to pick, where that database lives, where you have the sufficient resources if you want to build some of this stuff up, on the fly. There's one other thing I always like for very large data sets, the time to build these pre-aggregates can get larger. And so in some cases, it might mean like, well, before I can interact with this instantaneous response, I might need to wait like 5 or 10 seconds. But then all of my explorations with that chart will be hyper fast. In some cases, especially when you have really fine bins, so maybe lots and lots of data points that you're aggregating over, even in that binned space, you can also have issues where it might take even longer to build those pre-aggregates. And one nice thing about this framework is that you can actually do that offline. So if you knew you wanted to provide an experience, you could generate the pre-aggregates for the interactions you want to support ahead of time. And in fact, even if you want to, even just ship those, not even ship the original database, and run those through Mosaic as well.
And so just to confirm, Jeff, is this architectural strategy that you identify possible within Ridge too? So if we had a very large enterprise, that was keen on getting this type of performance on billions of records, and they were willing to put in the energy to engineer a high performance database within their kind of company ecosystem, and then pre-compute those aggregates in advance so that when the executive came in the morning, all they would need to do is break the glass, and this responsiveness that you've shown could be possible within Ridge on these larger data sets if they were willing to invest the engineering effort?
Yeah, so certainly possible, and it's certainly part of our larger vision. But I will say that what we're focused now is actually on really optimizing that purely browser-based experience. Largely because what we've been focusing on is helping businesses show value to their users and customers. And so that typically you're not shipping like an entire table. You may have done some aggregation already. You might not be showing all of the raw records, and it's going to be partitioned, by your different customers. And so what we're seeing out in the field is oftentimes this gives you in the range of anywhere from like tens to hundreds of thousands to maybe the low millions of records, where this browser-based regime still performs really well. That said, one of the nice things about the architecture is then we have the flexibility that, as we expand and as customers need it, we can do things like, spin up your own DuckDB instance maybe in a container and run against that, one that's kind of pushed to the edge as far as possible. Or there could be situations where, as you were saying, if customers have their own, high performance database, we could actually be talking to that directly through Mosaic as well. That hasn't been, sort of the business use case that we've been targeting yet. But again, one of the things that I really like about a solid technology is that it gives you this room to maneuver and grow over time. And so we're very optimistic that Mosaic provides that for us.
So it seems like a rough guideline from what you're saying for using Mosaic is likely kind of do some level of pre-aggregation and filtering to get it down to millions of records. And then you can get the super fast performance in the browser.
If you want to go in a pure browser delivery, yes,
Yep.
that's right.
Yep. Mm-hmm.
Right. And then it seems also like your focus on the browser is very punctual at this moment in order to get the embedded analytics use case going, right? Because one of the main things that, in addition to just kind of mechanical performance being slow, another real problem with data analytics inside of the enterprise is that the data is not available inside of the user's workflow. And so it seems that getting that embedded into the browser use case really nailed is the thing that's going to help to really circumvent this problem where in order to get the data analytics, the user needed to previously depart from their workflow, go someplace else, get the data, and then come back. Whereas when you embed into the browser, you can meet them right where they're at.
Yeah, absolutely. I mean, so we want to meet people where they are. We want to bring the data into existing products and experiences where it can be useful, actionable, and then compared with whatever other aspects of the product that people want to show. And that's true for a dashboard or a set of visualizations to interact with. And one of the things that we're also doing at Ridge, as you noted earlier, is pairing that with AI-powered data agents. And so if you see, for example, an interesting pattern and you want to know more, you have questions that the dashboard itself doesn't answer quite as readily, you can go type that in. And then that exact same data running in that exact same client-side database can be queried. And then you can get new visualizations there on the fly, which of course are fully participating in that Mosaic lifecycle. So doesn't matter if the charts came predefined in the dashboard or were generated on the fly by the LLM, they're all participating in Mosaic. They can cross-filter. And so you also get that really quick response. You might have to wait for however long the LLM takes to do its thing, but then we can do that immediately, run the queries, create the visualizations there. And then any query workloads that you're generating, that's all there in the client. You're not having to pay a cloud bill. You just pulled the data out once, and then you can kind of query to your heart's delight.
That creates a really rich experience inside of Ridge to have that piece of whatever I type in the LLM, create in the LLM side of things is completely interactive with everything else in the dashboard and vice versa that we don't get in other tools, which leads to another question I have of, is there a Mosaic MCP?
Oh, great question. I'd say stay tuned. There's some of my collaborators have built Mosaic applications with corresponding MCPs. We haven't done that yet, but MCPs and integrations are one of the high priority things that we're turning our attention to shortly at Ridge. So I'd say thanks for the teaser, and hope to be able to share more very soon. So I'd love to share just one more quick demo. Before we just saw dancing bar charts. This is showing that same flights data. We see the departure time along the x-axis. The y-axis is showing that arrival delay. But now we're actually seeing it as a bivariate plot. So this is one, rich visualizations where we're doing almost like pixel level binning to see this density of all of these flights. It's also overlaid with a regression fit, just to give a sort of a directional sense of how things are changing. But just to show some more capabilities, I can still drag out a selection brush. But now it's just limiting that regression fit and now being recalculated on the fly, each thing. And so the optimizations that we apply to pre-aggregate actually apply to the same statistical aggregations that can underlie techniques like regression. And so if you want to see regimes where maybe the relationship is changing, if you have maybe a hunch that may be the case, you can explore in this way. So just trying to give a flavor of some of the versatility and range of the types of optimizations that Mosaic can support.
That is so much what people want, but don't know how to say that that's what I want when they're asking for a dashboard, for example, to help them dynamically answer those questions. That is super impressive work.
And it's really the dream come true of an executive to be able to see that level of fidelity in their business at that responsiveness.
So to me, one of the benefits of this is for the people who are consuming and interacting with a visualization in that cycle of visual analytics, they're able to ask more questions and get answers that much faster. And to what you said earlier, Jeff, about that speed of interaction changing the nature of the questions that they're going to ask too.
Yeah, absolutely. I mean, we want to help visualization developers and creators, humans, and now including LLMs as well, to get to these things faster, get them so that they'll be correct, and then the viewers then hopefully can then discover more. So get those initial kind of overview insights, but then dig in deeper and really learn more about what's happening in their data.
The visualization creators, I don't know how much it can be underestimated, overestimated, but just the advantages to this, where the tool is automatically applying the pre-aggregations based on what you specified in the visualization, what you specified for filtering and brushing and dynamic. And so it's dynamic and responsive to that. So you don't need all of that data engineering work that is needed to load data into the cube necessarily, or do all this pre-aggregation for different charts. That's a huge win right there.
Yeah, we really, the vision here was like solving a cold start problems. Like you have the data, now you want to get at it. Obviously you need to define the visualizations, but you really just want to get going, see the data, work through it. I don't want to sit there and wait hours or longer for some big cube or index to build. I want to look at it now. And so the approach here is that we can do like a quick scan over the data to build just that little mini cube that we need for the questions that we're asking right now. We can do that, and in many cases just directly in the browser itself.
And get that richness of interactivity between visualizations that have been produced in advance by an analyst and the interactivity with the visualizations that are produced on the fly by the data agent answering those long tail questions. I mean, it really is a step change in terms of sucking out the extra effort from every step of the insight creation process. We're making things easier for the creator, easier and faster for the consumer, deeper, richer interactivity across the board. It's great.
Yeah, and the Mosaic library itself is open source. It's we're supporting it at Ridge, but it was originally developed in my lab at University of Washington alongside my collaborator Dominic Moritz at the Carnegie Mellon University. So that's open source software. If people want to go explore, play with the demos, or try building things of their own, we'd love to support you.
Love it. Well, thank you for joining us, Jeff, and really appreciate this tour de force of what you've done. Obviously, it's an entire career. It's been decades that you're working on this and other open source projects as well. Really appreciate you showing us the underpinnings and the inner workings of how this functions.
Yeah. Well, thank you so much for having me. It's been fun.
Let's make sense of this.
Let's make sense.